So, Professor Schmidt, the universe you described today is quite different from the universe we knew some years ago. How it happened?
Well, we went out and tried to measure the universe's past, and the beautiful thing about measuring the universe's past is that what is in the universe affects how the universe expands. And so by looking into the past, we can essentially weigh the universe and see what's in it. So when we did this work in 1998, we went and saw the trajectory of the universal expansion, the cosmic expansion, back in time, and we found out that the universe was speeding up in its expansion over time. Now, if the universe is full of atoms, or things with normal gravity, the universe cannot speed up. It needs to have something else in it. And that stuff we call dark energy, or Einstein called the cosmological constant. And we're not quite sure what it is, unfortunately, but it seems to be energy that is part of the fabric of space itself. And it, by the equations of general relativity, makes gravity push, and so it can make the universe speed up over time. So there's a lot of disagreements about what dark energy might be. The simplest idea is Einstein's. It is energy that is part of the fabric of space. At this point, that single explanation really is able to explain everything that we're able to measure of our universe. Of course, that doesn't mean it's right, and there are many, many theoretical ideas about other things that we want to test, but we need to have ideas of which to test before we can do that.
So we can say the dark energy is necessary to explain how the universe is working, even if we are not sure what it is.
I'm not sure I can say it's necessary. I would say it works, but it's not necessary at this point. You could imagine maybe changing how gravity works and replacing the need for general relativity, or for replacing the need for dark energy. But at this point, dark energy is the thing that I think works the best at explaining our observations.
But do we have instruments to try to measure or to understand something more about dark energy?
So there have been some huge projects planned to go out and to trace the expansion of space more and more accurately, because that's the one way we believe we understand dark energy can interact with the universe. So the idea is to go back and trace the expansion of the universe more and more accurately. The Euclid satellite is meant to do this. There are some big experiments here being planned on the ground. Unfortunately, we don't have a lab experiment where we can go through and try to look at space and say, yes, we can see what's going on. No one's come up with a way to do that. That would be great if we could, but the amount of stuff in the universe is so small when you average it out over the vastness of space that it's really hard to do those experiments here on Earth.